In this video, we're going to talk about parent functions and transformations. A family of functions is a group of functions with graphs that display one or more similar characteristics. A parent function is the simplest of the functions in a family. This is the function that is transformed to create other members in a family of functions. So we'll look at some basic parent functions. When y is equal to a constant, such as y equals 2, we call it a constant function. And the parent function of a constant function is when y equals 0. Next is a linear function, such as y equals 2x minus 1. The parent function of a linear function is y equals x. Next, we have a parabola or quadratic function. The parent function of the quadratic function is y equals x squared. Next, we have a cubic function. This is x to the third. That is the next parent function. Next parent function we have is y equals radical x. Next, we have a reciprocal function when y is equal to 1 over x. And we have an absolute value function, y equals absolute value of x. All these are examples of parent functions. Now let's talk about vertical and horizontal translations. Vertical translation happens when f of x, your parent function is plus k happens. If k is positive, the parent function will move upwards. If k is negative, the parent function will go downwards. So that's a vertical translation. Now, horizontal translation is when the parent function moves to the right or moves to the left. When you have f of x minus h, if h is positive, then the parent function will go to the right. If h is negative, that means it will be x plus h, because negative times negative is positive. When that happens, the parent function will shift to the left. And let's look at some examples. So we have a parent function, f of x equals absolute value of x. How does g of x, which is absolute value of x plus 3, will look like compared to the parent function? Well, there's going to be a vertical shift. Everything is going to move up 3. So it will look like absolute value of x, it's just that everything will go up 3. So I'm going to graph absolute value of x, which is the blue line, and absolute value of x plus 3, which is the red line. As you can see, this is absolute value of x. And what happened when you add 3? Everything moved up 3. Now what about absolute value of x plus 3? Notice this is x plus 3, not x minus 3. If it was x minus 3, then it would move to the right. However, this is the same thing as x minus negative 3, which means that the parent function, absolute value of x, will move to the left. So let's see what happens when we compare these two. You have absolute value of x. Notice, absolute value of x plus 3 moved to the left 3. Again, if it was absolute value of x minus 3, then it would move to the right. What about g of x equals absolute value of x minus 2 minus 3? There's going to be vertical and horizontal. First, it's going to move to the right 2 now because it's x minus 2. H is positive. Now the k is negative. So once after you move everything to the right twice, and then everything's going to go down 3. So let's compare these two graphs and see what happens. So everything, it moved to the right, 1, 2, and then you went down 1, 1, 2, 3. So there was a horizontal and vertical shift. Now, if g of x equals negative f of x, how would that graph look like compared to f of x? So for example, let's say g of x is negative x squared. How would that look like compared to x squared? What if g of x was negative absolute value of x? How would that look like compared to absolute value of x? Let's see what happens. So let's see what happens when we graph x squared and negative x squared. Here's x squared, and here's a negative x squared. So what happened? When there's a negative in front of f of x, it causes a reflection with respect to the x-axis. Let's look at absolute value of x and negative absolute value of x. So we have an absolute value of x and negative absolute value of x. Let's graph it. Again, here's absolute value of x, and negative absolute value of x is a reflection with respect to the x-axis. So basically flipped over respect to the x-axis. So how would you sketch this, knowing that the parent function is x squared? First, what I would do is I would first sketch x plus 2 squared. So there's going to be a horizontal translation to the left twice. Second, I would sketch negative x plus 2 squared. So after the horizontal translation, there's going to be a reflection with respect to the x-axis. And then everything's going to move up. Everything's going to move down once because you have a negative 1 at the end. So if you were to sketch this without the graphing calculator, you first want to probably sketch y equals x squared. And then it's going to move to the left twice. And then there's going to be a reflection with respect to the x. So it's going to go down like this. And then everything's going to go down once. So here's a new vertex. It's going to go down like that. Now let's use our graphing calculator, see if this is correct. So we have y equals x squared, and we want to graph negative quantity x plus 2 squared minus 1. So let's graph it. Here's our x squared, and notice it moved to the left twice, and then there was a reflection with respect to the x-axis, and then it went down, everything went down once. So you have a better graph using a graphing calculator.